Lesson 8. Controlling flow with conditions and loops. Statements in a JavaScript program generally execute in the order in which they appear, one after the other. Because this isn't always practical, most programming languages provide flow control statements that let you control the order in which code is executed. Functions are one type of flow control, and although a function might be defined first thing in your code, its statements can be executed anywhere in the script. In this chapter, you'll look at two other types of flow control in JavaScript: conditions, which allow a choice of different options depending on a value, and loops, which allow repetitive statements. The topics we will cover in Lesson 8 are the if statement, using shorthand conditional expressions, testing multiple conditions with if and else, using multiple conditions with switch, using for loops, using while loops, using do-while loops, working with loops, and looping through object properties. One of the most important features of a computer language is the capability to test and compare values. This allows your scripts to behave differently based on the values of variables or based on input from the user. The if statement is the main conditional statement in JavaScript. This statement means much the same in JavaScript as it does in English. For example, here's a typical conditional statement in English. If the phone rings, answer it. This statement consists of two parts, a condition and an action. The if statement in JavaScript works much the same way. Here is an example of a basic if statement. This statement includes a condition and an action. This statement checks the variable a and, if it has a value of 1, displays an alert message. Otherwise, it does nothing. If you use an if statement like in our example, you can use a single statement as the action. You can also use multiple statements for the action by enclosing them in braces, as shown here. This block of statements checks the variable a once again. If it finds a value of 1, it displays a message and sets a back to 0. The action part of an if statement can include any of the JavaScript statements you already know, and any others for that matter, but the condition part of the statement uses its own syntax. This is called a conditional expression. A conditional expression usually includes two values to be compared. These values can be variables, constants, or even expressions in themselves. Between the two values to be compared is a conditional operator. This operator tells JavaScript how to compare the two values. For instance, the is equal to operator is used to test whether the two values are equal. A variety of conditional operators is available. Often you'll want to check a variable for more than one possible value or check more than one variable at once. JavaScript includes logical operators, also known as Boolean operators, for this purpose. For example, these two statements check different conditions and use the same action. Using a logical operator, you can combine them into a single statement. This statement uses the logical OR operator to combine the conditions. Translated to English, this would be, if the phone number is blank or the email address is blank, display an error message. An additional logical operator is the AND operator. Consider this statement. This statement uses the AND operator instead of the OR operator, so the error message will only be displayed if both the email address and phone number variables are blank. In this particular case, OR is a better choice. The third logical operator is the exclamation mark, which means not. It can be used to invert an expression. In other words, a true expression would become false and a false one would become true. For example, here's a statement that uses the not operator. In this statement, the not operator inverts the conditions, so the action of the if statement is executed only if the phone number variable is not blank. The extra parentheses are necessary because all JavaScript conditions must be in parentheses. You could also use the not equal operator to simplify this statement. As with the previous statement, this alerts you if the phone number field is not blank. An additional feature of the if statement is the else keyword. Much like its English equivalent, else tells the JavaScript interpreter what to do if the condition isn't true. This is a simple example of the else keyword in action. This is a modified version of a previous example. This displays a message and resets the variable a if the condition is met. If the condition is not met, meaning a is not 1, a different message is displayed. In addition to the if statement, JavaScript provides a shorthand type of conditional expression that you can use to make quick decisions. This uses a peculiar syntax that is also found in other languages, such as C. A conditional expression looks like this. This assigns one of two values to the variable, one if the condition is true and another if it is false. Here is an example of a conditional expression. This statement might look confusing, but it is equivalent to this if statement. In other words, the value after the question mark will be used if the condition is true, and the value after the colon will be used if the condition is false. The colon represents the else portion of this statement and, like the else portion of the if statement, is optional. These shorthand expressions can be used anywhere JavaScript expects a value. They provide an easy way to make simple decisions about values. As an example, here's an easy way to display a grammatically correct message about a variable. This will print the message found one word if the counter variable has a value of 1, and found 2 words if its value is 2 or greater. This is one of the most common uses for a conditional expression. You can now create an example script using if and else. This example will use conditions to display a greeting that depends on the time. Good morning, good afternoon, good evening, or good day. To accomplish this, you can use a combination of several if statements. The first statement checks the hours variable for a value less than 10. In other words, it checks whether the current time is before 10 a.m. If so, it displays the greeting, good morning. The second statement checks whether the time is between 2 p.m. and 5 p.m. and, if so, displays good afternoon. This statement uses else if to indicate that this condition will only be tested if the previous one failed. If it's morning, there's no need to check whether it's afternoon. Similarly, the third statement checks for times after 5 p.m. and displays good evening. The final statement uses a simple else, meaning it will be executed if none of the previous conditions matched. This covers the times between 10 a.m. and 2 p.m. and displays good day. In order to try this example in a browser, you'll need an HTML file. We will keep the JavaScript code separate, so this list is the complete HTML file. You can save it as timegreet.html, but don't load it into the browser until you've prepared the JavaScript file in the next section. This listing shows the complete JavaScript file for the time greeting example. This uses the built-in date object functions to find the current date and store it in hours, mins, and secs variables. Next, document.write statements display the current time, and the if and else statements that were introduced earlier display an appropriate greeting. If you were to try this example, you would need to save this file as timegreet.js and then load the timegreet.html file into your browser. Figure 8.1 shows the results of this script. Here is another example of using several if statements in a row to test for different conditions. Although this is a compact way of doing things, this method can get messy if each if statement has its own block of code with several statements. As an alternative, JavaScript includes the switch statement, which enables you to combine several tests of the same variable or expression into a single block of statements. This statement shows the same example converted to use switch. The switch statement has several components. The initial switch statement. This statement includes the value to test in parentheses. Braces enclose the contents of the switch statement, similar to a function or an if statement. Each of these statements specifies a value to compare with the value specified in the switch statement. If the values match, the statements after the case statement are executed. Otherwise, the next case is tried. The break statement is used to end each case. This skips to the end of the switch. If break is not included, statements in multiple cases might be executed whether they match or not. Optionally, the default case can be included and followed by one or more statements that are executed if none of the other cases were matched. The for keyword is the first tool to consider for creating loops. A for loop typically uses a variable called a counter or an index to keep track of how many times the loop is executed, and it stops when the counter reaches a certain number. A basic for statement looks like this. There are 3 parameters to the for loop separated by semicolons. The first parameter specifies a variable and assigns an initial value to it. This is called the initial expression because it sets up the initial state for the loop. The second parameter is a condition that must remain true to keep the loop running. This is called the condition of the loop. The third parameter is a statement that executes with each iteration of the loop. This is called the increment expression because it is typically used to increment the counter. The increment expression executes at the end of each loop iteration. After the 3 parameters are specified, a left brace is used to signal the beginning of a block. A right brace is used at the end of the block. All the statements between the braces will be executed with each iteration of the loop. The parameters for a for loop may sound a bit confusing, but once you're used to it, you'll use for loops frequently. Here is a simple example of this type of loop. These statements define a loop that uses the variable I, initializes it with the value of 0, and loops as long as the value of I is less than 10. The increment expression I++ adds 1 to the value of I with each iteration of the loop. Because this happens at the end of the loop, the output will list the numbers 0 through 9. When a loop includes only a single statement between the braces, as in this example, you can omit the braces if you want. This statement defines the same loop without braces. The loop in this example contains a document.write statement that will be repeatedly executed. To see just what this loop does, you can add it to a script section of an HTML document as shown here. Notice that the loop was only executed 9 times. This is because the conditional is I is less than 10. When the counter I is incremented to 10, the expression is no longer true. If you need the loop to count to 10, you can change the conditional. Either I is less than or equal to 10, or I is less than 11 will work fine. The structure of the for loop in JavaScript is based on Java, which in turn is based on C. Although it is traditionally used to count from one number to another, you can use just about any statement for the initialization, condition, and increment. However, there's usually a better way to do other types of loops with the while keyword, which we will talk about next. Another keyword for loops in JavaScript is while. Unlike for loops, while loops don't necessarily use a variable to count. Instead, they execute as long as a condition is true. In fact, if the condition starts out as false, the statements won't execute at all. The while statement includes the condition in parentheses, and it is followed by a block of statements within braces, just like a for loop. Here is a simple while loop. This loop uses a counter, n, to iterate through the values array. Rather than stopping at a certain count, however, it stops when the total of the values reaches 10. You may have figured out that you could have done the same thing with a for loop. As a matter of fact, the for loop is nothing more than a special kind of while loop that handles an initialization and an increment for you. You can generally use while for any loop. However, it's best to choose whichever type of loop makes the most sense for the job or that takes the least amount of typing. JavaScript 1.2 introduced a third type of loop, the do-while loop. Here is a typical do-while loop. As you've probably noticed, this is basically an upside-down version of our earlier while example. There is one difference. With the do loop, the condition is tested at the end of the loop. This means that the statements in the loop will always be executed at least once, even if the condition is never true. Although you can use simple for and while loops for straightforward tasks, there are some considerations you should make when using more complicated loops. Coming up, we'll look at infinite loops and the break and continue statements, which give you more control over your loop. The for and while loops give you quite a bit of control over the loop. In some cases, this can cause problems if you're not careful. For example, look at this loop code. There's a mistake in this example. The condition of the while loop refers to the I variable, but that variable doesn't actually change during the loop. This creates an infinite loop. The loop will continue executing until the user stops it or until it generates an error of some kind. Infinite loops can't always be stopped by the user except by quitting the browser, and some loops can even prevent the browser from quitting or cause a crash. Obviously, infinite loops are something to avoid. They can also be difficult to spot because JavaScript won't give you an error that actually tells you there is an infinite loop. So each time you create a loop in a script, you should be careful to make sure there's a way out. Occasionally, you might want to create an infinite loop deliberately. This might include situations when you want your program to execute until the user stops it, or if you are providing an escape route with the break statement, which we will talk about next. Here's an easy way to create an infinite loop. Because the value true is the conditional, the loop will always find its condition to be true. There is one way out of an infinite loop. You can use the break statement during a loop to exit it immediately and continue with the first statement after the loop. Here is a simple example of the use of break. Although the while statement is set up as an infinite loop, the if statement checks the corresponding value of an array. If it finds a value of 1, it exits the loop. When the JavaScript interpreter encounters a break statement, it skips the rest of the loop and continues the script with the first statement after the right brace at the loop's end. You can use the break statement in any type of loop, whether infinite or not. This provides an easy way to exit if an error occurs or if another condition is met. One more statement is available to help you control the execution of statements in a loop. The continue statement skips the rest of the loop, but, unlike break, it continues with the next iteration of the loop. Here is a simple example. This script uses a for loop to print out scores for 20 students stored in the score array. The if statement is used to check for scores with a value of 0. The script assumes that a score of 0 means that the student didn't take the test, so it continues the loop without printing that score. A third type of loop is available in JavaScript. The for-in loop is not as flexible as an ordinary for or while loop. Instead, it is specifically designed to perform an operation on each property of an object. For example, the navigator object contains properties that describe the user's browser. You can use for-in to display this object's properties. Like an ordinary for loop, this type of loop uses an index variable, I in the example. For each iteration of the loop, the variable is set to the next property of the object. This makes it easy when you need to check or modify each of an object's properties. To apply your knowledge of loops, you will now learn how to create a script that deals with arrays using loops. As you go along, try to imagine how difficult it would be without JavaScript's looping features. This simple script will prompt the user for a series of names. After all of the names have been entered, it will display the list of names in a numbered list. To begin the script, you first need to initialize some variables. The names array will store the names the user enters. You don't know how many names will be entered, so you don't need to specify a dimension for the array. The I variable will be used as a counter in the loops. Next, the prompt statement should be used to prompt the user for a series of names. You can use a loop to repeat the prompt for each name. You want the user to enter at least one name, so a do loop is ideal. This loop prompts for a string called next. If a name was entered and isn't blank, it's stored as the next entry in the names array. The I counter is then incremented. The loop repeats until the user doesn't enter a name or clicks cancel in the prompt dialog. Next, your script can display the number of names that was entered. This statement displays the length property of the names array surrounded by level 2 header tags for emphasis. Next, the script should display all the names in the order they were entered. Because the names are in an array, the for-in loop is a good choice. Here you have a for-in loop that loops through the names array, assigning the counter I to each index in turn. The script then prints the name with a list tag as an item in an ordered list. Before and after the loop, the script prints beginning and ending ordered list tags. You've now seen everything you need for a working script. These examples show the HTML file and the JavaScript file. If you want to try this example, you will need to save the JavaScript file as loops.js and then load the HTML document into a browser. You'll be prompted for one name at a time. Enter several names and then click Cancel to indicate that you're finished. This shows what the final result should look like in a browser. In this lesson, you've learned two ways to control the flow of your scripts. First, you learned how to use the if statement to evaluate conditional expressions and react to them. You also learned a shorthand form of conditional expression using the question mark operator and the switch statement for working with multiple conditions. You also learned about JavaScript's looping capabilities using for, while, and other loops, and how to control loops further using the break and continue statements. Lastly, you looked at the for-in loop for working with each property of an object. You can now test your knowledge in the quiz area, access the scripts we learned in the lab, or go through the lesson again. The choice is yours. Thank you for choosing Sam's Teach Yourself.